Hello everyone, today's lecture is on system of linear equations. Before we be able to define what a system of linear equation is, we need to know what a linear equation is. A linear equation is an equation of the form y equals to x plus 1. Now this is linear equation because none of the variables in here are raised to a power greater than 1. Therefore, this is a linear equation. So if I add another equation to it, so 2y plus 5 equals x, this is another linear equation. So if I add another linear equation to our first equation, then what I have is a system of linear equations. Therefore, a system of linear equations is a set of linear equations with the same variables. Now, in this example, I have two equations, which is equation 1 and equation 2. And I have two variables, which are my x and my y. Therefore, this is a system of two linear equations with two unknowns. Now, the integer values in front of the variables are what we call the coefficients. So, in equation 1, the coefficient of y is 1, coefficient of x is 1, and in equation 2, the coefficient of x is 1, and the coefficient of y is 2. So these are what we call the coefficients, and the x's and the y's are our variables. Now, if I have another equation, which is x plus y minus 2z equals to 3, x plus y minus z equals to 7, and I have 3x minus 2y plus 5z equals to 9. Now, because I have three number of equations with three unknowns, which is x, y, and z, this is a system of three equations with three unknowns. Therefore, if I have a system that is represented as a11 x1 plus up to a1m xn, this is equal to b1, then am1 x1 up to amm xn, this is equal to bn. Then this is what we call a system of m linear equations with n unknowns, and the coefficients of this equation are a11, a1m up to amn, and the variables are x1 up to xn. So this is a system of m linear equations with n unknowns, and the coefficients are the a11 up to amn. So normally, when you have a system of equation, we would like to know how the solution will look like, or to find a solution to such a system so that we can make informed decision. So a solution to a system of linear equation is assigned values to these variables x's and y's and z's such that each equation in the system is satisfied. Now, if we put together all these solutions, then what we form is called a solution set. So if we have a system which is x minus y equals to 3, x plus y equals to 7. Now, if we solve that system, we'll have x equals to 5 and y equals to 2. So if we put this together, which is 5, 2, then this is what we call the solution set. Solution set of the system. And there are several ways that, or several algorithms for solving a system of linear equations. The ones that we'll be looking at in this lecture are the substitution method. We'll also be looking at the graphing. And then we'll also be performing some row reduction to find solution to our system. So back to the first equation, which was x minus y equals to 3, x plus y equals to 7. Now, using the substitution method, we can pick either equation 1 or equation 2 and then manipulate it, substitute it back to, assuming this is equation 1, this is equation 2. Manipulate any of the equations or make either y or x the subject in any of the equations and substitute in the other equation. So if we pick equation 1 and make x the subject there, then we have x equals 3 plus y. Now if we substitute this equation into equation 2, then we have 3 plus y plus the y that was remaining is equal to 7. So we have 2y equals 7 minus 3. 2y equals 4. Therefore, our y equals 2. So after finding the value of y, we substitute this value into x is equals to 3 plus y. So we have x is equals to 3 plus y, but we know that our y is equals to 2, therefore our x is equals to 3 plus 2, which is equals to 5. So the solution set to this problem is 5, 2. That is for the substitution method. Another approach that we can also use is the row reduction. Now the row reduction is simply putting our system into what we call an augmented matrix so that we can perform row reduction on a matrix to achieve an echelon form. An echelon form is getting or reducing your matrix into an upper triangular matrix. So if this is a full matrix, 1, 2, 3, 4, then an upper triangular matrix is in a matrix whose components below the leading diagonals are 0. So we have 1, 2, 4, then I have 0 here. So this is an upper triangular matrix. All the components above the leading diagonal, including the leading diagonal, are integer values aside 0, and all the integers below the leading diagonal are zeros.